Okay, so I was talking to you about the fact that you need to think about how electrons are arranged around an atom as being like its address. And that address you can think about as being called its electron configuration. Electron configuration. That's a big fancy word for how the electrons are arranged around an atom. How those electrons are arranged around an atom. They're going to be different for each element because each element has different numbers of electrons. Now, please keep in mind something. The number of protons is what identifies the element. It is fixed. It cannot change. However, you can change the number of electrons. So you can have two elements that have the exact same electron configuration. As a matter of fact, we're going to learn that sometimes atoms will gain or lose electrons just so they can behave like others. But that's for next chapter. So let's go. Electron configurations, how they, their address, if you will. There are some rules that we're going to go over, and let's talk about those. The three rules. The first one is called aufbau, the aufbau principle, that says the electrons are going to enter lowest energy levels first. You can't just jump up and go to the top energy level. You got to start at the bottom and move up just like everybody else. Then there's the one that's called Pauli exclusion principle that says each one of those orbitals that I drew for you, or that I didn't draw them, I showed you, says each one of those can only hold 2 electrons. And then Hund, that word is, I know it looks like Hund, but it's spelled Hund. Hund's rule says if you have orbitals that are exactly the same, like you have your p's, let's say you have p orbitals. Remember, if you have p orbitals, you're going to have one this way, you're going to have one that's up and down like this, and then you're going to have one that's like this. They're going to enter 1 electron here, 1 electron here, and 1 electron here until they all get 1 in them, and then they're going to start doubling up. And notice that I drew each one of those electrons all go in the same direction. And you got to keep in mind why it would do that. Electrons are negatively charged. They don't want to be together if they can help it. Okay, like charges repel each other. So the farther away from each other they can stay, the better they like it. All right. Okay. This is a good diagram that I often use. We just, from Prescott, had a lot of people leave to go overseas to serve our country, and they are staying in barracks. So I want you to think about this as being an army barracks. And the commanding officers, they're living down here someplace. Here's where the generals are, right way down here, okay? And now, so these are their barracks up in here. And here's the lowest private down here. And you have to start there. And no more than 2 guys can live in each one of these apartments, if you will. Each one of these barracks. No more than 2. But you have to start down there. So you're going to live in there, and this is the first energy level. And if you live on there, that's where they're going to fill up first. Now please understand, they use boxes here because it's way easier to draw boxes than the actual shape. But the actual shape of this particular orbital is actually going to be a sphere, an s orbital. Alright? So we're good there? But this is how they're going to fill up. You're going to fill up the 1 s first, then you're going to fill up the 2 s's, then you're going to fill up the 2 p's, and then the 3 s's, and the 3 p's, and so on and so on and so on. This is how they're going to fill up. So if you want to get a phone and get a picture of that, you need this, or it's in your book. That's how they're going to fill up. And this all has to do with energy. They're going to fill up lowest energy first. And then Pauli exclusion says you can only have two, no more than 2 electrons in any given orbital. Okay, and if they are in the same orbital, they're going to have opposite spins. Again, that's to stay as far away from each other as possible. And then Hund's rule says if you do have electrons that are in this, that are equal energy, like I showed you back here, these, let's say that you have soldiers that are living in identical barracks, these right here, then you got 3 guys moving in. They're not all going to move in together. They're going to each move into separate barracks, and then a 4th guy moves in. Now somebody's going to have to double up. That's what Hund's rule says, that they're going to live separate if they can, then they'll double up if they have to. Okay? That's what Hund's rule says. So here's how that they're going to fill up. Here's hydrogen. I wish they'd done this upside down, because always before they had everything starting at the bottom. So I want you to imagine, please, if you will, this being turned upside down. This hydrogen here being turned upside down. Always before they had this on the bottom, and now they put it up top. So imagine this turned upside down here. Okay. Here's your 1s. So notice what it says. He lives on the 1st floor. This is what it would be his address when he's writing home. He lives in an S-shaped orbital. He was the 1st guy to move in. If helium comes and moves in, he lives on the 1st floor. He lives in an S-shaped orbital. He was the 2nd guy to move in. So it's really not that hard to do. Here's lithium. Where does lithium live? Well, only 2 guys can live on that 1st floor. So you have to prove that it's full. How do you prove it's full? Well, you tell it, that 1st floor is full, Sarge. So now I've got to move to the 2nd floor. I live in an S-shaped orbital. I'm the 1st guy. And that's how you do electron configurations. Thankfully, you can use the periodic table to help you, and that's exactly what we're going to use. I'm going to show you how to do that. Let's see. I guess I'm going to have to find a periodic table. Let me see if I can pull one up right quick. I don't know how to do that on here. I don't know if it will let me. Let me see. Yes. You're going to be so happy to see my drawing. It's going to be fabulous. Oh, no, I want here. I want graph paper. And I want to be able... Here's a beautiful periodic table. Just like the one that's in our classroom here. Here's hydrogen up here, and it's beautiful. I'm just doing a fabulous job. And here's helium up here, okay? And then it goes like so, and like so, and like so, and like so. Okay. And I know I don't have them all drawn, but you're going to get the idea. Here's 1, oops, no, okay. Here's 1, here's 2, here's 3, here's 4, here's 5, here's 6. All right, and here's 7. Now, you're actually going to see that these numbers over to the side that you can see on the big periodic table that's in our classroom, they actually represent the floors, the levels, the energy levels, the rungs on that ladder, if you will. Okay, so here's hydrogen right here. He lives in the 1st floor, and look at what's more than that, guys. Look at here. All of these guys that are in these 2 rows right here, all of these are S-shaped apartments. These are S orbitals. It's called the S block on the periodic table. This block right over here is your P block. P block. There should be 6. I don't know if I've got 6 in there. 1, 2, 3, 4, 5. Oops, we're going to pretend it's 6. Okay, I'm going to draw another one. Let me just draw. Oops, now we got 6. Okay. All right, we're good. 6. Okay, because there are 6 p orbitals all together. So this is our p block. I'm going to change this color right here. Let me change it to, I don't know what color. Okay, this right here is the p block. Okay. So if this guy lives in this apartment over here, any of these over here, he lives in a p orbital. And then you have this one that's in the middle here. All of these are your D's. Okay, and those that are down at the very, very bottom that I didn't draw on here, those are your F's, and we're not going to talk about F's in this chemistry class. When you get into college, then you talk about them, okay? But these are all your S's. So you can basically look, and I ought to be able to point to something like here, this is this one right here. This is the 5th energy level. This is an S orbital, and he was the second guy to move in there. So if I tell you 5s2, you should be able to look at the chart and say, oh, that's strontium. But that's not good enough, guys. You can't just say, oh, 5s2 is strontium. You have to be able to fill in all the rest. You got to be able to say 1s2, 2s2, 2p6, 3s2. You have to fill in all of the others. Why do you have to do that? To prove to the generals, do all that paperwork like they have to do in the military, to show that all of the other stuff was full before you moved in to the 5s2 apartment or orbital. Okay? And we're going to practice these because they're not the easiest thing that you've ever done. But if you understand this, you're going to understand next chapter. It really has a purpose and a plan, I promise. Okay? Be ready. Be ready. Okay? Be ready to sketch me an s orbital. Here's you an s orbital. Here's you an s orbital. Here's you a p orbital. Here's you a d orbital. Really kind of looks like a 4-leaf clover. And an f orbital looks like a flower. It's got 7 lobes on it. Okay? Be ready to sketch those. See ya.